Hello everyone. Welcome to today's seminar series. I am Ibrahim Bagheri. I'm a professor of electrical, computer, and biomedical engineering at Toronto Metropolitan University, and I am the program director for the NSERC Create on Responsible AI. I am very, very pleased to welcome our speakers today. Professor Katina Michael is a professor with Arizona State University and a senior global futures scientist with the Global Futures Laboratory, and has a joint appointment with the School for the Future of Innovation in Society and the School of Computing and Augmented Intelligence. She has been funded by the National Science Foundation, the Canadian Social Sciences and Humanities Research Council, and the Australian Research Council. She's the director of the Society Policy Engineering Collective and the founding editor-in-chief of IEEE Transactions on Technology and Society. She's also the founding chair of the inaugural Master of Science in Public Interest Technology. Prior to academia, Dr. Michael was employed with Nortel Networks, Anderson Consulting, and Otis Elevator Company. I'm also pleased to welcome Professor Jordan Richard Schoener, if I'm not mispronouncing, who's an assistant professor with the Department of Psychology at Concordia and adjunct research professor with the Department of Psychology and a member of the Institute for Data Science at Carleton. He's a former postdoc with the University of Ottawa Skills and Simulation Center and a former visiting scholar with the U.S. Military Academy. He has acted as an ethics consultant for the Ombudsman Integrity and Resolution Office, the Office of the Chief Scientist, Health Canada, the Canadian Border Services Agency, and the Department of National Defense. His primary areas of research interest are learning and decision-making and metacognition with application in cyber psychology, cybersecurity, disinformation, ethical AI, and explainable AI, and organizational behavior, such as incivility, insider threat, and knowledge management. He also serves as a research fellow with the Center of AI and Digital Policy and as a member of the Canadian Association of Chiefs of Police Artificial Intelligence Steering Committee. I believe we are also including the work of Professor Roba Abbas, who's a senior lecturer of operations and systems of the Faculty of Business and Law at University of Wollongong in Australia, and they send their regrets. So thank you again for joining us, and the virtual floor is all yours.
Well, it's great to be with you all this evening. I think it's lunchtime there in Toronto, but we are honored for the invitation, and we will speak to you today about designing AI using human-centered approach, or the human or our human-centered approach, explainability and accuracy towards trustworthiness. My name is Katina Michael, and as Ibrahim introduced me, I'm from Arizona State University. I'm joined by my long-term collaborator virtually and on pre-record, Dr. Roba Abbas from the University of Wollongong in the School of Business, who is also the co-editor-in-chief of the IEEE Transactions on Technology and Society, and of course by Jordan Schoener from Concordia University with affiliations at Carleton University as well, a local to Canada. Together with Pablo Rivas of Baylor University in the US and Teresa Anderson, formerly of the University of Technology, Sydney, now with Pebble Consulting, we bring you a full paper that is open access and available through the IEEE Explore database, where we have included during this session quotations. You will find those full quotations in this paper. Within a few months, the paper has been well downloaded, and I'm sure over time will also be cited. But we bring something quite unique to you from the perspective of AI. A lot of people talk about human-centeredness or the human-centered approach. Very few describe what it is beyond the buzz terms, and we hope we might unpack that today in 3 parts. The first part, where I speak about explainability and accuracy towards trustworthiness in AI systems. Roba will offer more on the literature surrounding human-centered design with respect to 3 main themes. And finally, we'll finish with Jordan on the social cognitive approaches to AI in addition to a brief discussion before Q&A from you. We will keep to time, and so please do log your questions either in the chat and feel free to interact with us throughout the presentation, but also to leave the questions to the end if you so wish. So a brief overview on the concept of artificial intelligence, and it's become a concept that inspires reverence and fear in the hearts of many, and users, organizations, and politicians do like to talk about the promises of AI, but also the perils of AI. And some of those perils actually play out on the large stage, on large scale, and do a lot for what's called trust in AI. Although sometimes the public is none the wiser and they forget very quickly over AI mishaps. And at other times, we do believe that those teething problems will be overcome with time. But whether it's business or government, the promises are great for citizenry. With respect to businesses, we're always promised greater revenues. With respect to potentially calculating supply and demand in new ways, and given the context and use in terms of developing innovative business solutions and business transformation. We always hear about that digital transformation that AI will herald in that time. In terms of government, there are usually three or more reasons, but the main ones are that it is revenue generating in some ways for AI to be used and incorporated within government to catch tax cheats, to perhaps increase penalties and rates depending on context where there's been fraudulent behavior. In other times, it's a cost saving on labor, and at other times, it has to do with compliance. But all of this usually is about one of those three items that I just mentioned, but we are exploring new drivers for AI in business and government, and quite interestingly, within the context of the public interest. How can citizens be acquiring and adopting AI to support them in their social activities, whether that has to do with scheduling sport on the weekend for children in the area, groups meeting up through Rotary organizations or other third parties, and not-for-profits and non-government organizations. So the promise is great. And the question is, how will these systems develop in terms of explainability and accuracy, and how do we maintain that human-centeredness throughout? So with that, once we've touted those benefits, we also see a lot of vulnerabilities with respect to AI and challenges, and some of those vulnerabilities include poorly written algorithms, the use of poisoned or incomplete or skewed training data sets that really marginalize the already marginalized individuals. So we're talking about vulnerable communities here. The use of geolocation data to determine tariffs that negatively affect the customer. Discrimination based on someone's gender or predicted sexual orientation. Failures of cybersecurity leading to leaks in confidential and sensitive information of data subjects. So all of these are known vulnerabilities, but there are challenges as well. How do we better test AI systems with existing data sets so that we know that they're working correctly in a vast array and diverse contexts? The lack of alignment between algorithm design and the designated system's goals or objectives, and that's a big thing when we're talking about socio-technical systems. What are those goals or objectives? And it can't be making more money or reducing costs. There has to be a real human goal and objective behind our orientation to introduce new technology. I would rather hear personally of goals such as a reduction in poverty rather than catch those poor tax cheats. These are better goals to frame in the affirmative sense, and then we could have those flow-on effects that we talked about a moment ago to do with cost savings, revenue generation, or compliance. So the goal has to be one that is real and not based on monetary terms. I'll stress that throughout the presentation. The embedded biases in the data are also challenges. For example, if more males who of a particular race are placed behind bars and incarcerated, what does that do to the algorithm? Should we be using that data to actually train data sets when we know potentially that will place Black ethnic minority groups or other minority groups on the back foot before you have even begun with regards to AI predictive analysis? The lack of end user and broader stakeholder consultation, and that stakeholder consultation will be spoken about later by Dr. Abbas, and an inability to effectively forecast future events, among other reasons. These are all challenges. You know, we can say that AI can help us predict, but do we say that those events will actually unfold? And when that becomes critically specific to contexts such as medical illness or actual financial decisions, that inability to effectively forecast actually means there's a liability. At what point in the future will these liabilities actually be enforced? Now, one of the major problems that we see, we mentioned it a moment ago, is this notion of dirty data. Data is a fundamental element that we use to train data sets and pre-train our machine learning algorithms. That's why I have it highlighted here in the blue. Personally, I think a lot of it begins with the data, and we often look to systems to build because the data exists. So an asset generates the data, it collects the data, it gathers the data, but that's our only impetus for our goal. The data exists, we can use it. The question then becomes, what are those applications in society that we do need critically, and how do we gather that right data? Okay, so we have temperature data dating back to who knows when, hundreds of years. We have it at a monthly, at an hourly, at a minute level. We have time of day data about how people move around particular areas around our nation states, our provinces, our local districts, even our collection districts. The question then becomes, how do we collect the data that we require, and how do we ensure, to begin with, that the data that's being collected is not dirty? Already we are seeing third-party applications such as Snapchat and many other social media platforms using AI clients to create users who are really de facto data annotators and data labelers. It's quite interesting to see young boys, for example, interact. I was driving a vehicle of about 6 children not long ago, and we were all talking about the perils and the benefits of AI. And they were using Snapchat at the time of the travel. And it became known to me during this time that Snapchat is actually using children as annotators. How does that happen? An AI client comes up, a child is taking a snap, they do this thing called streaks, where they send each other images for 250 days straight, and they don't miss a beat in doing that. But in so doing, using their AI client, they're pushed to information to actually respond with. So the push might well be, is this a banana? Or is this a chair? And the child innocently will reply, no, this is my car, this is where I am, this is what I'm doing, this is a beach, this is the sun, this is a tree, this is a dog, this is, Joe down the street. Quite interestingly, as we continue to refine labels of objects, we are using free labor, and I would call it subscriber work, to actually annotate and label. How ethical is that is another question, but we're here to talk mostly in this slide about the 3 different areas. We can have data issues, design and algorithmic issues, and implementation and interpretability issues. All of these issues do stem and start to multiply when they build one on top of the other. If we start with the data, is the data dirty? And most data scientists that have been surveyed by Kaggle, for example, in 2017, think categorically dirty data is their single biggest burden. Well, how do we clean that up? How do we ensure our AI and machine learning systems are based on clean data, data that is accurate, data that we have received the consent of individuals to gather, data that is appropriately being used in a design of an algorithm and executed properly, and that which can be interpreted, that which once implemented actually means something. So for those who don't know, data annotation requires that we label data to ensure that objects are recognizable to machines. So if I hold up a pen, it knows it's a pen after being trained. If I play a sound of a horn of a car in a congested area, the machine learning algorithm begins to understand and differentiate between what is a horn and what is perhaps a glass breaking. Data labeling, on the other hand, is about adding more information or metadata to a piece of data to better train the ML model. And this is when we're talking about the use of children in labeling and many others, for example. So this is time consuming and expensive to clean data. I used to work in the field of GIS, Geographic Information Systems, and anyone who's dealt with address data or any type of quantitative data or data to do with customer records knows what I'm talking about. We used to estimate between 40 and 50% of data sets on average, with about 8 million records, for example, was dirty. But over time, we are finding strategies to overcome this. So a few definitions to go back to the title of this presentation, looking at two dimensions, explainability and accuracy, towards this notion of trustworthiness in AI systems. We also here have bolded the word transparency. How is transparency linked to explainability? So explainability is associated with the notion of explanation as an interface between humans and a decision maker that is at the same time both an accurate proxy of the decision maker and comprehensible to humans. This is a definition proposed by Arietta et al. After surveying 400 or so articles. It is about understanding why an AI succeeds or fails, how it uses information provided by data subjects, and how it makes decisions and more. Trustworthiness, on the other hand, remains grounded in objective criteria, and those criteria can be identified as efficiency, speed, reliability, and accuracy. But at the same time, trustworthiness also requires subjective beliefs in the security and performance of the AI. So trustworthiness is a complex topic. Both objective criteria and subjective beliefs are necessary. Predictive accuracy may be instituted using machine learning. It may come sometimes at the expense of our ability to access the knowledge within the machine. So it might well be accurate, but I may not know and be able to explain how I came to that outcome. So there is a huge tie between these two dimensions of explainability and accuracy. In terms of transparency, the basic elements of data and decisions must be available for inspection during and after the use of the AI. If a user has access to their data or can see how a decision is made, then there's a degree of transparency. But if I can't get into the data, it's said not to be transparent. We can actually call that a black box. So if I look at the two dimensions here, which is in the title of our paper, explainability and accuracy towards trustworthiness, let's for a moment consider a financial application. Let's say I want to invest in shares, and I use an AI to predict which shares I should devise my money and divide my money between. So data should always be accurate. Those are the variables that we often rely on to make a calculation. These must be accurate. And then on the right hand, you can see all of these dimensions, some of which Dr. Abbas will talk about in a moment, such as explainability and more. And while some researchers have suggested that there is an accuracy explainability trade-off, we claim both are important to the success of any AI. Some people claim, well, if it's accurate, who cares about the explanation? I just trust the system. It's trustworthy. It's proven itself time and time again. But when it comes down to critical situations such as medical illness predictions, not only would you want to know, perhaps, how it has devised a potential predictor, perhaps some disease that may happen, but you want to know that the medical data that is stored on you is actually accurate. So we can see that there may be one or more dimensions we can fill this page with, and it's not really a trade-off. It's not a zero-sum game here. We are not saying accuracy versus explainability. We are saying we require all of these dimensions to be working together towards trustworthiness. Let's take a very fundamental example. I say to a system, as I sit in front of it as a human, I trust you, machine, algorithm, and data. Really? What is this notion of trust if not personification? And personification, as many of us know through a literary device, gives human characteristics to non-human things or inanimate objects. The non-human things can be animals, objects, an AI, or a concept, and the human characteristics given to these things can be emotions, behaviors, or actions that bring non-human things to life. Now, we've often talked about the sentience of AI, but without getting too deep here, We often say to the person next to you or me, I trust you. I can also look up and say, well, I trust in the heavens, or I trust in God or this superior being, or may actually say, I trust my dog more than I trust people. The question is, where do we place our trust? But is it actually logical to be placing a personified human characteristic on a non-human thing? And many people have diverse answers for that. But personifying the value of trust in an inanimate object is considered by some to be unconstructive. There can be no bi-directional trust. Is the machine going to turn around to you as the user and say, I trust you? Probably not at the moment. So there can't be some connection there between a human and a thing, or can there be? Although we can speak of trustworthy systems or the goal of trustworthiness as an outcome. So I do want to stress here that we don't really talk about trust in machines or algorithms, but when we talk about AI, we should be talking about trustworthiness or being trustworthy. For instance, a movie recommender system might consistently prove and provide relevant results, yet the reviewer might not be aware or even care about how those recommendations were determined. But one way to operationalize trustworthiness is subjective confidence that a model will act as intended when facing a given problem. So let's go back to that black box for a moment. And it's really important here to look at the opaqueness of black boxes. We know there's an input, something transforms the raw data, and there's an output. The input is a stimulus. There is some activity within the black box that you can't see as a user, and the output is a response. Sometimes we call the black box an area where an experimentation can come back, and as an observer, there is a feedback. The question then becomes, how do I reduce the complexity in the black box? The great Norbert Wiener in 1961 called this the unknown system. He said, how do we better understand and how do we reduce the complexity in this unknown system? He said that in 1961. So we want to go from this black opaqueness to this white glass box. And the question becomes, how do we reduce the complexity? How do we what happens when we lose? There is a loss of context and the required precision when we're trying to explain to users what's actually going on in that black box, so that users understand what happens to the AI. And this is quite common as a practice. But a user will be faced with this question of what is going on in the black box through the human interface. And this is where this black box might be within an embedded system. It may well be within an implantable device in the future. It may be in a wearable device. The question is, what is going on and how do we explain this to the end user? How do we increase the confidence of the end user? Does the end user always require an explanation about something, or in some instances, would an explanation actually reduce their trustworthiness or the trustworthiness of an AI? So with that, I'm going to stop sharing and begin the session, followed by Dr. Robert Abbas of the School of Business at the University of Wollongong, who will share with us some notions of the human-centered approach.
Thank you, Professor Michael. Building on the foundations just established regarding explainability and accuracy and the connection with trustworthiness, we will now move on to establishing what this all means with respect to AI design. Our interest is in highlighting the need for a human-centered approach to AI design, one that builds on existing scholarship in the field of human-computer interaction in a broad sense and explainable AI more specifically. But first, let's briefly discuss the value of explainability and accuracy with respect to decision-making processes. This discussion is framed from the position that AI should support decision-making processes by attending to tasks such as gathering, processing, analyzing, and representing data. In essence, offering useful information and patterns in a fitting manner so as to aid human decision makers. Ideally, decision-making support would entail the provision of information and reasoning that facilitates an understanding of functioning. This is where we can reference literature, some of which we document in our related publication that we can share post this presentation, that underscores the significance of perceiving decision-making as a socio-technical process or system. From this perspective, so from the socio-technical perspective, we are effectively endeavoring to explore and understand the interface between the social and the technical elements. That is, related studies tend to emphasize the empowerment of the decision maker through the use of AI, as opposed to removing the human completely from the loop. This directly relates to our discussion of explainability and accuracy and the linkage with trustworthiness. For instance, if the human is out of the loop, this may impede our ability to attain explainability and accuracy toward trustworthiness. This is indeed a challenge, as when we consider the primary objective or goal of explainable AI, it is apparent that trustworthiness is often regarded as a key socio-technical system objective. Additionally, there are complementary goals, which you can see on your slide, and they're found in the literature. These include causality, transferability, informativeness, confidence, fairness, accessibility, interactivity, and privacy awareness. And what we highlight in our work is the requirement for an additional goal, that of human-centeredness, thus requiring us to integrate core principles of human-centered design and human-centered AI as a subset of that broader philosophy as we progress toward the operationalization of human-centered principles. But prior to addressing human-centeredness, we look to seminal works in the areas of explainable AI design, notably work intersecting areas such as ethical AI, explainability, accuracy, and trustworthiness. From our review of the literature, it's evident that there are many complex factors, dimensions, and considerations pertaining to explainable AI design, and these draw on diverse disciplinary perspectives. We'll be presenting three prominent themes and interrelated themes today as part of this talk. These themes naturally lead to that requirement that I mentioned earlier to reshape AI or explainable AI design goals in a way that allows for the integration of that additional goal of human-centeredness. And we'd like to note here that our review of literature is deliberately contained to the seminal works and major themes, and is intended to be demonstrative of those prominent themes that allow for an exploration of, an exploration and a direct link between the need for explainable AI and a process of human-centered AI design. One which in fact seeks to address socio-technical tensions when considering current developments in AI from a technological perspective, and also the corresponding societal implications. In terms of the first theme, we have here the first theme focused on the value of interdisciplinarity and context to explainable AI design. In our research of seminal works, we examine and reference studies that seek to address concerns of accountability through enabling user control and oversight. Such studies review design and evaluation method across disciplinary boundaries, highlighting the importance of cross-disciplinarity, of context awareness or context-aware perspectives, and maintaining that these are critical for designing and evaluating explainable AI systems. Represented here on the current slide are disciplinary silos. We maintain that in order to achieve explainability and accuracy toward trustworthiness, there is a requirement for those working in and across these and other disciplines to provide input into socio-technical design processes. For instance, we need experts and specialists in machine learning, visualization, human-computer interaction, the cognitive sciences, anthropology, and others to contribute and to collaborate. The outcomes of such collaboration should ideally be reflected in deliberate design decisions that facilitate transparency as a system requirement, such as those that allow for the creation of explainable interfaces. For instance, and as a representative example, carefully considered interdisciplinary interface design decisions may contribute to algorithmic transparency by ensuring that reasoning behind machine learning decisions are available to the end user in a suitable form. And we wish to note here that solutions and designs for algorithmic transparency will inevitably differ from one application area to the next. And that's where context awareness as part of that first theme comes into play. This leads well into the next theme, regarding user interaction as related to explainability, or explanations more specifically, where seminal works cite the need to explore specific exchanges supplemented by an assessment and understanding of mental models relevant to AI-based systems. Noted on the slide here as an information about the importance of measurement and evaluation of explainable AI systems and machine or human-to-machine performance in the first point. And in the second, details about the nature of explanations. Explanations can best be regarded as interactions as opposed to statements, and these are often influenced and informed by individual user experiences, understanding, and motivation. It's here that the idea of understanding mental models becomes increasingly important, particularly with respect to trust in AI systems. Furthermore, the literature notes that trust is not a single stable state. And here, and in the interest of time, I'll refer you to our paper for further information. But essentially, authors such as Hoffman et al. Call for a framing of explanation as exploration. That is, an exploratory process of sense-making. And I quote here from our paper, it is in this process, so in this sense-making process, where cognitive and affective uncertainty must be navigated both responsibly to build and maintain trust, but also imaginatively to support the curiosity needed to persist in the engagement and to experience the uncertainty of the situation positively. This relates to better understanding of mental models regarding an AI system. Here we can utilize systems thinking tools such as the iceberg model presented on the slide to engage in human-centered AI design that allows for an exploration of events, of patterns and trends, underlying structures, mental models, allowing for those mental models to be better understood, and in turn allowing for an exploration of the complex nature of explainable AI and human-centered AI systems. And while on the topic of complexity, we move on to our third theme, whereby we look at explainable AI design literature as pertaining to multi-stakeholder perspectives. Significantly, the recognition of the diverse stakeholders across the AI ecosystem. And this theme, in fact, relates closely to the prior two, in that we need to consider end-user perspectives reflected in lived experience. That's part of theme two, in addition to interdisciplinary perspectives that may be reflected in expertise or may reflect expertise as part of that initial theme that we presented. And these result in a multitude of questions that apply to multiple stakeholders, which require responses. You can see some of these questions on your slide. So they require responses and also require us to work through potentially divergent stakeholder interests, inclusive of those interests of industry, government, third sector, and other stakeholders. And there's much to say on this point, but in the interest of time, we have included one example that attempts to map the AI ecosystem and demonstrate the importance of a multi-stakeholder perspective. And there are many others that exist across both professional and public spaces. However, for the purpose of this presentation, we suggest that we supplement such resources with tools and approaches to human-centered design operationalization that consider interdisciplinary perspectives. The aim here is on human-centered, value-sensitive, socio-technical systems design, utilizing participatory and co-design processes and approaches. And this allows us to ideally ensure explainability and accuracy toward trustworthiness. This proposed approach to design advocates for the dissolving of disciplinary boundaries, those silos that we introduced earlier, looking to disciplines such as psychology, indeed social psychology, to gain a deeper appreciation of those human and psychological needs as we consider mental models and other elements. And this will allow for AI design to be approached from a social cognitive angle, which will now be discussed. Thank you.
When it comes to understanding social cognition of design, there's a number of different resources that we can draw upon. The first, of course, goes back to old school perceptual research, where a guy by the name of J.J. Gibson came up with this idea of perceptual affordances. J.J. Gibson's notion was a radical departure from what people had discussed at the time in terms of perception. He thought an affordance was an interactional property that emerged as a consequence of an individual living with some kind of material object. Now, that idea is a little bit too loosey-goosey for operationalization. So a lot of other cognitive psychologists came along, most notably Donald Norman, who again has written quite extensively on the psychology of design, and made affordances into a much more concrete representation. So we can think of this as the functional properties that are assigned to an object. Last year, I published a book that looks at the ethics of artificial intelligence from an interdisciplinary perspective. So I'm going to talk to you a little bit about that framework right now. In terms of affordances, I try to identify 3 different types that you can think of. The first is what you think of as the technical affordances. And so when you're talking to someone that's an expert, a designer, that let's say understands things about coding, et cetera, they're really thinking about the technical affordances of the system. They're primarily focusing, I would say, exclusively on that. When you think potentially more about a user and what they're looking at, then you can bring in this notion of a functional affordances. They're more interested in understanding how they're going to interact with the object, what it can do for them, et cetera. The final dimension that I think people are becoming much more aware of with respect to this movement towards ethical AI and explainable AI are the social and ethical affordances of a system. And this is, of course, where things get tricky. Again, we live in theory in an objective world. For the most part, we rely on intersubjective agreement about what people can and can't do, what isn't the case about reality. And this is where we get to the social and ethical divide here. So we talk about social affordances. This really relates to the social categories that define a society. And therefore, this can become quite complex very quickly. Different societies may share different social categories. In other words, we're talking about protected categories, who may deserve some form of affirmative action, who's being discriminated against. That all depends on the categories that you have that you're using to classify people. And that can become more problematic if 2 individuals or 2 groups do not share the same set of social categories. You can contrast that quite sharply with the idea of an ethical affordances. An ethical affordance is something that is systematic. It is about ethics, it's about rationality. It ideally should be something objective that we could talk about, in contrast to something like subjective morality. Again, we could have a whole lecture on that. I'm not going to get into that. But the reason why we need to be interested in this is, again, from a cognitive psychologist perspective or cognitive science perspective, when you interact with an object, you're engaging in what we call cognitive offloading. In other words, you become dependent upon that object. It performs a set of operations for you. And this is where that notion of trust comes into play. In other words, are we trusting the system to a certain, to the appropriate amount? And again, objectively, of course, what would that be? That would be, again, studies of accuracy and reliability. But of course, most people don't have access to that information. They're going to get that information through intermediaries. So they're going to focus on experts and how experts have validated a particular approach. So again, we're going to try to dive into some of those topics. Again, first, a big step back here. When it comes to understanding systems design, we really need to think about a basic distinction that we use in cognitive science. So we talk about 2 different types of learning and decision-making systems. Contemporary research wants to be agnostic about this, so we tend to call these system 1 and system 2 types of operations. So type 1 systems are what most people would call as unconscious systems or automatic systems. They tend to be fast and they require few cognitive resources. These systems have an important vulnerability. They can actually learn extremely complex multidimensional categories. So as an example, if you saw a bird fly through the sky, you'd instantaneously categorize it as a bird. The problem is this system needs feedback within 2.5 seconds. If it doesn't get it, it's not going to learn. The other major problem, of course, is that these representations that we have in our head are what we call cognitively impenetrable. We may not be aware that they're there. We may not be aware of their properties because ostensibly they're non-verbalizable. You can contrast those learning systems, what we call type 2 systems. Type 2 systems are slow, they're deliberate, they tend to be what people would call conscious, and they require a lot of mental resources. So things like attention and working memory, which are distributed neuroanatomical regions that work together. So when we talk about cognitive psychology, we're really talking about functional systems, not neuroanatomical regions per se. Now, why is this important? This is important because when a user interacting with any kind of design, we really need to ask ourselves which one of these types of systems is coming into play here. And we know that humans can be extremely vulnerable when it comes to interaction with systems. Why? Because you and I tend to default to what we call type 1 systems or system 1. In other words, we assume that, due to humans, encountering novel features of their environment, they want to free up these cognitive resources. So we want to rely on automaticity whenever we can. And this becomes a problem when we look at things like design. So a number of studies are out there that have suggested, as an example, when people are presented with end user license agreements or privacy statements when you're downloading, let's say, an app, maximum amount of time people tend to pay is around 73 seconds. And people have gone in, they've done the computations based on the average reading time, based on the number of pages in a privacy document. Essentially you'd need your lifetime to actually go through all the privacy statements that you're presented with. So in other words, it's not realistic to assume that users have actually gone through these statements. Instead, they're relying in theory on trust, that the app has been put there by a reliable developer, that it's distributed through an app store by someone that's also reliable, and potentially that it's going to be tweaked and modified by people that are reliable as well. We also see this sort of vulnerability happen in a very different setting. So if you think about things like social media, we know there's significant problems with the spread of disinformation. Why? Because people are sucked in by clickbait. They tend to read the headlines. They tend to spread them around without really thinking deeply about them either. And that's especially true of affectively valenced headlines. And so when we're thinking about systems design, we need to take that into consideration. And you'll have recognized this since we've all lived through COVID-19. Instagram, Facebook, they all tried to slow us down a bit by asking you, do you want to share this information? Do you actually trust it? So that's at least one basic limited attempt at trying to slow down this information sharing process. This also can be related to, unsurprisingly, to the science of heuristics and biases. Now, again, this is a whole other domain in and of itself. There are different camps here. I'm just going to talk about what heuristics are in general, though. Perhaps the most well-researched and well-funded research program comes from Amos Tversky and Daniel Kahneman, which won Kahneman the Nobel Prize in Behavioral Economics. And so what they've done is gone through and listed all the ways that we're susceptible systematically to certain kinds of information. So one of the most prominent ones we call the availability heuristic. People go for information that's immediately available to them in their environment or that can be easily retrieved from memory. Concurrently, we also see what we call base rate neglect. So people tend to ignore statistical information. Instead, they primarily rely on stereotypes, other kinds of rules in their head, instead of looking at the actual numbers. Another heuristic that tends to be a bit more exotic, but one that you experience on a day-to-day basis, what we call hindsight bias, or the appropriately named the I knew it all along effect. So if information is revealed to you, you reframe it in your head as if you knew that you were given that information and you knew it all the time, which means that people tend to rationalize choices, decisions that they've made, even if they are not to their benefit. And so when we're thinking about things like agreeing to, privacy statements that ultimately are not to our best interest, people are more likely going to rationalize, well, nothing's really going to happen to me. That data is anonymized. It's not a big deal. So we need to be aware of this. Where we see these heuristics exploited is this idea of behavioral nudging. So behavioral nudging in a very straightforward way is, how can we make a user make a choice they might not otherwise make? So this technique typically doesn't work when people have some kind of entrenched opinion. So if you're a liberal or you're a conservative, et cetera, and you're very hardcore into this, we're not going to be able to push you. But if you're on the edge, what you can actually do is get people to vote maybe one way or another way. And you see this happen a lot in online retailers. Some of them will automatically tack on some kind of a policy, right? So in other words, if something breaks down, et cetera, you've already got that policy tacked on in the shopping cart. You might not notice. And once you've actually gone through the checkout and bought it, you're less inclined to go back and undo the transaction, okay? Another major problem we see as well is failures of affective forecasting. So we're not good at predicting how we're going to feel about something in the future. And again, classically, this is framed in terms of prospect theory. Again, another contribution by Tversky and Kahneman. So you tend to discount gains or outcomes that are long-term. You tend to go for more short-term, immediate outcomes instead. And so you need to be aware that these heuristics are being exploited when you're engaging with systems. And again, you'll know this too, especially if you're an academic. You'll go in, you'll try to download something that says, will you accept all these cookies? Or will you just accept your own choice of cookies, et cetera? And ultimately, the default tends to be what? It's favoring the developer instead of you as the user. But of course, you could just pause for a moment and you can detect that problem. Another thing, again, I'm going to talk about this really briefly because we've lost time at various ways throughout the process here. We also need to think about something called algorithmic aversion. So what exactly is this? In some cases, people are averse to using algorithms, or in another domain, they're averse to using non-human systems. So the classic example of this, of course, goes back to the 1970s. A Japanese engineer by the name of Matsuo Mori came up with this notion of uncanny valley. As you blend human and non-human, specifically robotic characteristics, you see that there's this valley, this area, this region of negative affect where things are creepy. So something kind of looks human, but it's not entirely human. If someone kind of moves in a human way, but it's not entirely human, you start experiencing this cognitive dissonance, this negative affective experience that ultimately shapes the way you trust what you're seeing, how you respond to it. Now, my research in this looks at the extent to which all of this can actually be explained pretty readily. It's all about frequency of exposure. The more familiar you are with a domain, with some type of technology, the more likely you're going to trust it. Now, why is this relevant to what we're talking about today? Well, in social psychology, we're always talking about stereotypes. But again, around a couple decades ago, people tried to come up with unified models to describe how we see all stereotypes. And as it turns out, a very robust model is actually quite simple. We assume that all stereotypes can be understood in terms of two broad social dimensions: perceived competence and perceived warmth. And you can fit all stereotypes along this dimension, where if a group is high in competence and warmth, it's an in-group, you tend to trust it. If it's low in competence or low in warmth or both, you tend to distrust it because they're out-groups. Now, this is a study I conducted that looks at technological categories that are thrown into this kind of framework. And what you wind up finding out is this: the most trusted categories, those that are perceived to be the most competent and reliable, are not even humans. They're dogs and smartphones, right? So why would dogs and smartphones be the most trusted? Because it's a relatively innocuous device. You're used to it. You're used to relying on it. You've got a timer. It will alert you to things. You've got a calendar on there. You're able to search for information. That frequency of interaction might make you more susceptible to this. You might say, well, what's the problem? Again, in the same study, what did I also do? Well, I gave people the option of course, reading artificial intelligence. Now notice, artificial intelligence is the technology that undergirds your mobile phone. And yet, in terms of perceived warmth, it's significantly lower. So because you're packaging up this AI in what I like to call a domesticated technology, you have an entirely different perspective on what it is, an entirely different level of trustworthiness that results. Now, again, I'm only going to go through this briefly because we're running out of time here. But I want to get, very quickly to this notion of explainability. Explainability, really kicks off in terms of a research program in 2016 when DARPA started throwing out money to look at this. But in fact, the notion of explainability and using mathematical models to understand intelligence actually goes back to the 1800s. There's an area of psychology which not a lot of people know about called psychophysics. And they were primarily interested in coming up with mathematical models to understand perception. And so what they were concerned with doing is just coming up with an equation. They weren't concerned about really labeling what these individual factors in the equation were per se. And you see the same sort of thing when you get to early models of perception. So this is what we call a perceptron. So it's a physical model that has an input layer and an output layer. So this is the precursor to all computationally implemented connectionist networks. Okay. So again, we're facing the same problem here. If you ask someone to describe this, they could. If you ask someone to interpret the results, they could. But if you ask someone to explain what was going on here in a nitty-gritty manner, they wouldn't be able to do that. So this notion of explainability becomes very important. And you see that some systems now have a bit of explainable AI built into them. So you can look at this screenshot here. I mean, this is the way ChatGPT describes the way it's functioning. And it's giving you some relatively intuitive explanations which grab your attention. But in the end, we also need to ask, even though these things might be reasonable explanations, are they accurate? Because simply because something is believable does not mean it's accurate representation. And remember, the other element here too, when we talk about explainability is ultimately relative to the audience. What does the person know? What's their level of understanding? What's their motivation? What are they trying to get out of this? And the last thing I'm going to say here, I'll kind of cut my portion of the talk kind of short, is that we know that there are differences between the kinds of explanations we will accept. So I've got a few papers floating around in various stages of peer review that look at this. We give people explanations that are mechanistic, that are functional, or that are intentional. And what we wind up finding out is, regardless of the validity of the explanation, people prefer mechanistic explanations to functional explanations. That's where they look, okay? But if you give someone a scenario, they tend to default to looking at the functional explanations because that makes sense to them. But if you present a scenario where a system fails, then they start defaulting to look for mechanistic explanations. So it's not the function where there's a problem, right? Overall, the function is not performing as it should. So what they do is they shift downward and they start asking about what is going on mechanistically. And then I'll just finish on this note here. This is where this idea of a socio-technical system comes into play. Ultimately, it's about mapping out the relations between people and technology, because at one given point, people and technology aren't together. They represent as two different things in a joint ecosystem. But over time, what happens is, through joint interaction, people start becoming dependent on these technologies. And that's in psychology where we talk about things like distributed or extended cognition. After a time, you're so used to offloading your cognitive processes onto these external systems, you no longer try to develop those competencies and skills yourself. So going back to one of the themes where we started that Katina mentioned, you see this with things like ChatGPT. It may be that, in fact, writing will become an art form that very few people are capable of. Much like, photography replaced painting, you might see the same kind of thing happen with ChatGPT replacing a lot of people's ability to write academic papers. So I'll let Katina finish up. Thank you for listening to my portion of the talk.
Thank you so much, Jordan. That was riveting. And to Dr. Abbas, thank you. I think Ibrahim and Calvin will pass back to you.
Thank you very much. This was very, very, very interesting. So thank you very much.